Hello, this is Sunil Ladekar. My topic for the final project is Logstash. Here is the agenda, and I'm going to talk about the logs have problems. What is Logstash? Logstash architecture, advantages and goals of Logstash, and we will learn about how to install the Logstash and its directory layout. I will show you demo and how does it work. And at the end, conclusion, references and reports. Unstructured data and logs have problems. What is the problem we can solve here using Logstash for unstructured data? The first problem is here, there is no consistent format. Every device and applications we have, they try to log in their own way. There is no standardization in logging mechanism. There are too many date formats. We cannot search across them because of the inconsistency in the format and difficult to perform searches. And we need to know everything about every log in order to extract value from that specific data. Expert knowledge is required. People are interested in the logs, such as business people who care about financial data, often do not have access to read the logs, understand the data, where the logs are. The second problem is here, there are so many time formats. If you want to look at this, as you may know, if you look at and think this is right about today. But if you count this, it is sometimes during 1900. The time 2208 988 800 corresponds to midnight 00 1st Jan 1970 GMT. So according to the time protocol in RFC 868, it is 2208 988 800L. Here is another one, which is date timestamp format, and we don't know what year this was. Here is another, the date format, at least we know date, month, year here. Plus 000 is an HHMM offset from UTC GMT, and in this case the time you are getting back is exactly UTC. We don't know when this happened. So third problem, logs are not centralized. Logs are spread across all of your servers and devices. Now there is the Internet of Things is a thing which we will have to deal with it. Many times single server will have different kinds of logs and it's hard to search. The tools like grep is not scalable. Problems of reading data like this. We always have problem reading at logs or data when they are not properly organized or structured. It creates a lot of frustration when we start looking at the unorganized data. This is hard to read and understand. Most of the time we don't know what the error means. Logstash is going to help us solve these problems. What is Logstash? Logstash is a tool for managing events and logs. You can use it to collect logs, parse them and store them for later use, like for searching. Speaking of searching, Logstash comes with a web interface for searching and drilling into all of your logs. Logstash is a flexible open source data collection, parsing and enrichment pipeline designed to efficiently process a growing list of log, event and unstructured data sources for distribution into a variety of outputs, including Elasticsearch. Logstash is an event processing engine. As you can see, there are a lot of different ways to get the data into the Logstash. Once it's in Logstash, there are a lot of different ways that you can process it, filter it, and do various actions to its richer data, and then send it out to backside to outputs. Elasticsearch and lots of other third-party tools, files and network systems can be used. It is very versatile engine for processing your data. Logstash supports multiple inputs such as reading multiple files through the multiple TCP ports per Logstash instance. However, each event only enters through the one input. Each event can have multiple filters. We can have multiple outputs per event through files, the TCP sockets and Elasticsearch, etc. The filters are applied to the order in which they appear. We can apply graph, date, filter, and also event can be applied on various filters or even on previous filters. Logstash is for centralizing logs, collects, parse, transmit, interprets, and store forward. Logstash architecture. Logstash is a tool for receiving, processing, and outputting logs. All kinds of logs, system logs, web server logs, error logs, application logs, and just about anything you can throw at it. Sounds great, huh? Using Elasticsearch as a backend data store, Logstash acts as the workhorse, creating a powerful pipeline for storing, querying, and analyzing your logs. With an arsenal of built-in inputs, filters, codecs, and outputs, you can harness some powerful functionality with a small amount of effort. We can start by installing all the various pieces that work together to create our basic centralized logging server. The architecture can be a bit confusing at first. So, looking at the architecture diagram of the Logstash, each of the components does a specific task. Java runtime environment that Logstash uses to run. Logstash collects and processes the logs coming into the system. Elasticsearch. This is what stores, indexes, and allows for searching the logs. Also, Redis can be used as a queue and broker to feed messages and logs to Logstash. Kibana can be used for web interface for searching and analyzing logs stored by Elasticsearch. Strictly speaking, Logstash alone does not ensure meaningful and centralized management of log files. To perform its task as promised, Logstash needs some assistance. Logstash itself is a Java application, and despite all the prejudices that administrators have against Java, justified or not, the Logstash developers' decision go with Java was well founded, because Java is also installed on Windows as a matter of course. Logstash can include Windows log files in its collection. This would be difficult to achieve with other rsyslog services in many cases. A Logstash installation that extends over more than one server consists of at least 5 different services. Looking at this architecture, the central role is played by Logstash own components. The shipper. Basically, a client running on each target system collects log messages. In the next step, it sends them to the indexer, which interprets and processes the logs messages as the specified by the admin. Host on which the indexer is found generally also runs the Logstash web server, which offers admins a search box for log files. In the background, two other services that do not directly belong to Logstash but are different and important to its function go about their duties. The Redis message broker and elastic search storage and search environment. Redis is the focal point of communication between the shipper and the indexer. The Logstash instances on each server deliver their messages to the Redis server, where the Logstash indexer retrieves them later. Elasticsearch, also a Java application, builds the index in the background and provides the interface to which the Logstash web server forwards search requests from the web interface. Advantages and goals of Logstash. It is easy to enter input or gets the input from large logs data files as events, filtering event data and outputting events in the file format, HTTP format, visual graphical format, and even on the screen. It does not depend on Redis to manage failover itself. Instead, it sends events to one of two Redis instances. It is open source and ability to help shape the roadmap to solve problems and simplify logs review reporting process with the customization. It helps troubleshooting and monitoring. Logstash performs the task based upon the information stored in an conf files, which are easy to understand and write. It accomplishes goals such as resiliency, performance, and integrity. How to install the Logstash? This specific Logstash installs supported on Linux platform using mtool. In this case, first I need to install CentOS 6.6 VM. Alternatively, it can be installed on Linux or Windows platform. But for my project, I have used CentOS 6.6 for Logstash and Elasticsearch. I have created the yum install repository file to make the install easy and in the one-step process. Logstash repository file has the path to each packages, which is described in this slide. This is the snapshot of logstash.repo repository file from my CentOS 6.6 which I have created. Now I am creating the directory in the var run directory and then the logstash-web directory inside of it. Now I am executing yum command to install Logstash, Elasticsearch and its components. Once the installation is complete, I have configured to start the services on run level for Logstash and Elasticsearch. I have verified that Logstash works. Hence, I have tested using the simple command with inputting data manually and then sends the output to the screen as standard out. Here is the Logstash and Elasticsearch directory layout and path. Sometimes it is very hard to find the files for any modifications that are required. In this table, I have described directory type description for each and where are they located on CentOS OS, and these are the default path if not explicitly changed. Here is the demo, and for this demo I am using the Apache web server access log file. The file is very complicated and it was big in size, and I thought it is good to use the access log file. That was very hard to read it. This is very simple, is as simple does. So in this case I have started Logstash with entering input standard in and reporting the output standard out to the screen without using Elasticsearch, and I am getting this output very well organized. It's small but very well organized. In this second demo I have started Logstash with inputting data and sending it to the Elasticsearch for the better output format. With this, log is easily readable in Logstash web. I am executing here the curl Logstash web HTTP command to report the customized output that includes organized message and easily readable timestamp and hostname. I have opened the web browser. In this case I used localhost with search to monitor the structured data that was reported by the Logstash Elasticsearch. Now I can access this data from the web in proper way. I am running here top command at CentOS server to monitor the Logstash and Elastic processes and find out the server and application resources utilization. Furthermore, I was watching for processes that are running. Here is the Logstash and Elasticsearch. In this demo, I have created the Logstash conf file to use for filter grok and Elasticsearch for outputting the result. So I have input, I am using filtering grok with the timestamp and combined messages from the Apache log, and outputting using the or through the Elasticsearch as standard out. I am executing Logstash filter program here, which I have created. Furthermore, I am using the portion of unstructured logs from my web server as my input. Using the Elasticsearch, I am getting the organized logs in the customized format, as you can see adjacent. In this output now, I can easily read the messages, host server client IP, date, time, request and version information, number of bytes of data received, references and agent information. Now in this demo I am going to use this web server log file that is on my server, and I am going to access it through the Logstash, and I have a source code for that will call to the access log as input. This file was very huge and I copied inside the temp directory to run my program. So here is the source file, a conf file I am using for demo, and we will know how Logstash process them. So let's do something that's actually useful. I would like to process Apache 2 access log file. I am going to read the input from the file on the localhost and use a conditional upon process the event according to my needs. First, I create a file called logs-webs.conf with the contents described in this code. I change the logs file path to suit my needs. I copied the Apache 2 access log file to temp folder. If you want, you can provide the actual path as varlog apache 2 and then the file name access_log as well. But I am calling this as the input file which I configured above. That's temp and file name is access_log, which has the original log entries. You can see log files from any other web server also. Now I am running Logstash with the F flag to pass in the configuration file. Here is the syntax. Now I can see my Apache log data in Elasticsearch. In this case, Logstash has opened and read the specified input file, processing each event it encountered. Any additional lines logged to this file has also captured, processed by Logstash as events and stored in Elasticsearch. As an added steps, they are stashed with the field type set to Apache access. This is done by the type and Apache access line in the input configuration. In this configuration, I told Logstash for only watch the Apache access_log. But it's easy enough to watch both the access log and error log or even all the logs. You have to just specify more input file path. So here is the organized, parsed and meaningful output from Logstash for the specific web server log file. How we got the output like this? The Logstash agent has acted as a processing pipeline with 3 stages: inputs, filters and outputs. Inputs have generated the event, filters have modified them, and outputs have shipped them. We can see this Apache log data in the structure format because of Logstash and through the Elasticsearch. Here is the URL for Logstash and Elasticsearch that represents the logs data in HTTP or web format. Conclusion: I have summarized and concluded that the Logstash is a very elegant solution to centralize and organize logs. It is a log server with a robust built-in analysis tool which consolidates logs from many servers and make the data searchable, able to visualize and customize the logs. It is easy to configure and use it. Tens of thousands of lines can be easily read, can understand and help troubleshoot of any problems. Logs can be processed any data from any source. Logstash is a flexible, easy data collection, parsing, storing and enrichment pipeline. Logstash is the free, open source and free to use it however we want it in whatever way. Here are the references for Logstash, Elasticsearch guides, software downloads and links to many Logstash codes that are available. Here are the links to my project reports, Logstash codes, presentation slides and YouTube video. Thank you and have a great day.